Hello, so in this video we're going to look at chapter 7.1, multiplying and dividing rational expressions. In this section we're going to look at 5 different topics, and they're pretty close to each other, so if you can grasp them, they can go pretty quick. In the description below there will be the video chapters, so you can jump to the various sections that you want to see. There will be a link to the Openstax textbook, the first and second edition. There will be a shared folder that you're welcome to look at additional resources, handouts, notes, and examples, and then a survey at the bottom. So first, we're going to look at determining when the value of a rational expression is undefined. And this would be any time the denominator of our fraction is equal to 0. We are given 4x squared y all over 3y. And since we want to know where it would be undefined, we would take our denominator, set it equal to 0, and solve. And so if we took 3y equaling 0, we would see that y cannot equal 0, and that would be our answer, and that would be it. So next we have b minus 8 all over b squared minus 36. And so we would, since we want to know where it was undefined, we would take our denominator, set it equal to 0, so b squared minus 36 equaling 0, we would factor, and this would be a difference of squares, so we would have b plus 8, b minus 8 equaling 0, and we would see b plus 8, b minus 8 equaling 0, and we would see that b cannot equal plus or minus 8. So whether it be positive or negative, it would still give us a 36, and if they're subtracted, it would give us a 0 in the denominator, which would make it undefined. So now we're given 10w minus 5 all over 2w squared minus 11w plus 5. And so since we want to know where it is undefined, we would take our denominator, set it equal to 0, 2w squared minus 11w plus 5 equaling 0. And since we want to know how it factors, we could use the AC method, and we would see that it would be negative 10 and negative 1. Pulling those apart, we get 2w squared minus 10w minus 1w plus 5 equaling 0. If we look at our first pair and our second pair, we can see in the first pair that we have a 2w in common, which would leave behind a w minus 5. And in the second pair, since we want this w minus 5, we could multiply out a negative 1, and we would get a w minus 5 equaling 0. And we would set our factors to w minus 1, w minus 5 equaling 0. Set our factors equal to 0. And then we would just solve. So in the left, we would get 2w is equal to 1, and we would get w cannot equal 1/2. And we would also get w cannot equal 5. So next, we're going to be simplifying rational expressions. And we're going to take a polynomial over polynomial, and we're going to factor it. And if there's something that we can cancel in the top and the bottom, then we can get rid of it, because it would just equal 1. So if we had like an x plus 2 over an x plus 2, we could cancel that and we would just equal 1. So that's kind of what the idea of the simplifying rational expressions is. So first, we're starting with 8m cubed n all over 12mn squared. If we were to factor this, we would get a 2 times 2 times 2 times 3m's times n all over 2 times 2 times 3 times m times n times n. And since we want to see what cancels, we can see that our 2's cancels, another set of 2's cancels, 1m's cancel, and 1n's cancel. And so we're left with 2m squared all over 3n. In the next one, we're given x squared plus 4x minus 5 all over x squared minus 2x plus plus 1. If we were to factor, we can see that we have an x squared plus bx plus c, and we can go straight to the form, and we can get an x minus 1 and an x plus 5 all over x minus 1, x minus 1. If we look at the same process, what we have that can cancel, we can cancel an x minus 1 in the top and the bottom, and our answer would be x plus 5 all over x minus 1. So next we're given w cubed plus 216 all over w squared minus 36. We can see in the top that we have difference of cubes, so we could do w in parentheses cubed plus 6 cubed all over w in parentheses squared minus 6 in parentheses squared. Because we have a difference of squares on the bottom and we have a difference of cubes on the top. So in the bottom, we would get w plus 6, w minus 6. And in the top, we would get w plus 6 in parentheses and w squared minus 6w plus 36 in the top. And if we look at what cancels, we can see that a w plus 6 cancels and a w plus 6 cancels, and our answer would be w squared minus 6w plus 36 all over w minus 6. Next, we have 6u squared minus 10u minus 4 all over 2u squared plus 6u minus 20. If we looked at factoring the top, so 6u squared minus 10u minus 4, we can see that we can pull out a 2. Pulling out a 2, we get 3u squared minus 5u minus 2. If we were to use the AC method, we can see that it would be a negative 6 and a positive 1. And if we go through all the factors, we can get a 2, 3u plus 1, and a u minus 2. If we look at 2u squared plus 6u minus 20, if we pull out a 2, we're left with a u squared plus 3u minus 10. And we can see that is an x squared plus bx plus c form. We can go straight to the factored form, and we could use a 2 u plus 5 u minus 2. We can see that our 2's cancels, our u minus 2 and our u minus 2 cancels, and so our answer would be left with a 3u plus 1 all over a u plus 5. So next we're going to look at multiplying rational expressions. And so this is kind of the form that it is. So we have a over b times c over d, which is equal to ac all over bd. And so typically I would say, if it helps, label each of them a, b, c, d, and then factor each one of them individually, and then do all of your canceling and then solve. So in this one, we're given x squared plus 19x plus 84 all over 5x plus 20 times 6x plus 24 all over x squared plus 19 plus 84. And so we can see that we can do a, b, c, and d. And then for a, we know that we have a x squared plus bx plus c form. So we have x squared plus 19x plus 84. And if we look at the factored form for that, we would have a positive 12 and a positive 7. We would have an x plus 12 and an x plus 7. For b, if we pull out a 5, we would be left with an x plus 4. For c, we can see that if we pull out a 6, we are left with an x plus 4. And for D, it is the same as A, so we don't have to worry about doing that one again. If we rewrite it out so we can keep ourselves organized, we have an x plus 12, an x plus 7, all over 5x plus 4, times a 6x plus 4, all over an x plus 12, x plus 7. If we go back and cancel what we have in common, we have an x plus 12 in common in the top and the bottom, an x plus 7 in common on the top and the bottom, and an x plus 4 in common in the top and the bottom. So our answer would be equal to 6/5. So next we're given 5p squared all over p squared minus 5p minus 36 times p squared minus 16 all over 10p. If we look at labeling them, A, B, C, and D, we don't have to do anything with A and D, we just got to factor B and C. So for B, we have a p squared minus 5p minus 36. If we look at the form, we can see that it's an x squared plus bx plus c, and so we can go straight to our factored form, and we can see that we would have a positive 4 and a negative 9. And for C, we have a p squared minus 16, and we can see that as a difference of squares, so we can go straight to p plus 4, p minus 4. If we put it back into the equation, we could rewrite it as 5 p all over p plus 4 p minus 9 times p plus 4 p minus 4 all over 5 times 2 times p. If we go back and cancel what we have in common, we can see that 2 5s in the top and the bottom can cancel, a p in the top and the bottom can cancel, a p plus 4 in the top and the bottom can cancel. We're left with an answer of p minus 4 all over 2 times p minus 9 in parentheses. So next we're going to look at dividing rational expressions. And so the easiest way that I suggest to people is to look at KFC. I understand it's not Kentucky Fried Chicken, but it's keep, flip, and change. And so we're going to keep the first one, we're going to flip the second, and we're going to change our sign. So we're given n squared plus 14n plus 45 all over 11n plus 33 is being divided by n squared plus 16n plus 55 all over 9n plus 27. And so first, I would find all of your factored forms. So for A, we have n squared plus 14n plus 45, and we can write the factored form as n plus 9, n plus 5. For B, we have 11n plus 33. If we pull out an 11, we're left with an n plus 3. For C, we have n squared plus 16n plus 55. If we factor, we get an n plus 11 and an n plus 5. And for D, we have a 9n plus 27. If we pull out a 9, we're left with an n plus 3. So I'm going to rewrite it first. Now we can look at our KFC. So we're going to keep the first one, flip the second one, change the sign. So we'll have n plus 9, n plus 5 in parentheses, and 11, n plus 3 times 9, n plus 3 all over n plus 11, n plus 5. Now all we have to do is go back and cancel what's in common. And so we can see we have an n plus 3 in common in the top and the bottom. We have an n plus 5 in common in the top and the bottom. And we can see that that is all that we have left that can cancel. And so our answer would be 9 n plus 9 all over 11 n plus 11. So next we're given this rational expression, and we can write out our factored forms. And so we could do our factored forms and then do the KFC, or we can do KFC and then do our factored forms. Whichever is more comfortable for you is what I would recommend. I'm going to do the KFC first in this time. So we're going to do keep, flip, and change. So we have 2a squared minus a minus 21 all over 5a plus 20 being multiplied by a squared plus 8a plus 16 all over a squared plus 7a plus 12. If we write out our factored forms, in the top left we would get 2a minus 7 and a plus 3. In the bottom left we would get a 5x plus 4 times, in the top right we would get an a plus 4 and an a plus 4. And in the bottom right we would get an a plus 4, a plus 3. If we cancel what's in common, we have an a plus 4 in the top and the bottom, an a plus 4 in the top and the bottom, and we can see that we can cancel another a plus 4, and so our answer would be 2a minus 7 all over 5. So next we're given this rational expression, and we want to basically do the KFC, factor them out, and cancel what's in common and solve. And so my suggestion would be to do the KFC first for this one, because we have 3 different ones. So you would keep this one, flip the second one, and change the sign. So you'd have 4m plus 4 all over 2m minus 6 times, in the top you would have m squared minus 5m plus 6 all over m squared plus 5m plus 6 times 2m plus 4 all over 4m minus 4. If we look at factoring all of them, in the top left we would get 4m plus 1 all over 2m minus 3. In the top middle we would get an m minus 2, m minus 3 all over an m plus 2, m plus 3. In the top right, you would get a 2m plus 2 all over a 4m minus 1. If we look at canceling, we can see that we have a 2 in the bottom, a 2 in the top, a 4 in the top, and a 4 in the bottom, an m minus 3 in the bottom, and an m minus 3 in the top, and an m plus 2 in the top and the bottom. And we can see that that is it. And so our answer would be an m plus 1, m minus 2, all over m plus 3, m minus 1. So next we're going to look at determining the domain of a rational expression. And so the idea is that everything you're doing with multiplying and dividing rational expressions is going to be the same thing. You're doing the exact same thing, however you're just introducing function notation, where you have r of x is equal to f of x times g of x, or r of x is equal to f of x all over g of x, and g of x cannot equal 0. So now we're given r of x equals f of x times g of x, and so we can literally just do the same thing we've done before. So we have a 6x squared minus 12x all over x squared plus 7x minus 18. times x squared minus 81 all over 3x squared minus 27x. If we look at factoring them, we can see that in the top we get a 6x x minus 2. And in the bottom left, we get an x minus 2, x plus 9. In the top right, we can see that it's a difference of squares, so we have an x plus 9, x minus 9. In the bottom right, if we factor out the 3x, we are left with an x minus 9. If we go back and look at what we can cancel an x plus 9 in the top and the bottom, an x minus 9 in the top and the bottom, and an x minus 2 in the top and the bottom. And so we're left with r of x is equal to 6x over 3x, which would just give us 2. So r of x would equal 2. And so the process is very similar to when we multiply and divide rational expressions. It's the same process. It's just a matter of introducing function notation. So now we're given r of x is equals f of x divided g of x. And so we can look at writing it how we've seen it before, where we have 4x plus 28 all over 5x plus 60 being divided by x squared minus 49 all over x squared plus 17x plus 60. If we look at doing the KFC, keep, flip, change, we can write it as 4x plus 28 all over 5x plus 60 times x squared plus 17x plus 60 all over x squared minus 49. If we look at writing the factored forms, we would have 4x plus 7 over 5x plus 2. And then we would have an x plus 5, x plus 12, all over x plus 7, x minus 7. If we cancel what's in common, you can see we have an x plus 7 in the top and the bottom, x plus 12 in the top and the bottom. And so our final answer would be r of x is equal to 4x plus 5 all over 5x minus 7.